Okay, great. I think we'll kick it off. Thank you everyone for joining the next in our series of webinars. I'm TARRYN, here at ENCONA. I'm the marketing manager. ENCONA, what do? We're a global training, a consulting, auditing and technology firm. We have been around for 15 years. This year is our 15th anniversary. We do host these free webinars approximately every 6 weeks. And I'm very happy once again that we've got Trunkenpolz, who is our founder and chairman of the board. He keeps threatening to retire, but we keep giving him stuff to do. So thanks for joining us, Hans.
Yeah, thank you very much, TARRYN, and hello to everybody out there. Thanks for being today, and I hope I can provide some clarity to this topic of yours today.
Great. Thanks, Hans. Next up, we've also got Marc. We're very excited to have a guest this time around, Marc SCHAEFFERS from Datalyzer. Datalyzer is a global computer-aided quality software firm. And I believe you've been going since 1979 and work with over 4,000 clients, which is quite the achievement.
Correct. Thank you very much, TARRYN. Thanks for having me here, and nice to meet everybody.
Thanks, Marc. So it's very exciting. Also, we have a formal partnership between ENCONA and Datalyzer, bringing you both like the training aspects and the software. So first off, a couple house rules. Everybody's using the chat function. I think most people are quite used to these elements these days. Please go ahead and chat to one another and leave commentary. If I can ask, if you could use the Q&A function at the bottom of your screen for any questions you have. We will do a Q&A session towards the end of the webinar. Frankly, that helps me keep on top of it and not miss any interesting questions. Secondly, if you would like to speak during the webinar, you use the raise hand functionality. Again, I would probably open that up more towards the end of the Q&A session. And that's it. I hope everybody can hear us and see us clearly. So without any further ado, we pick the topics for these webinars based on what our clients ask us. Between sales teams or consultants, trainers, everything like that. And Hans, you brought forward the topic that you wanted to cover, how to conduct an effective R-FMEA. Why is it such a hot topic these days?
TARRYN, for two reasons I would like to bring forward in that respect. One is I firmly believe, and we see it out there, we still have quite some big issues with applying the traditional FMEA approach. And now a new terminology came in with the reverse FMEA, which created a lot of confusion out there in the industry and a lot of unclarity. And the second reason as to why we picked this topic is simply the fact that several OEMs are already responding on this R-FMEA and brought it forward into their customer-specific requirements, which makes it mandatory to follow for the global supply chains. And needless to mention, it became a very hot topic at this point in time. And we can see it also from all the calls that we get and requests that we get to provide clarification. And I believe this was a good point to identify this topic as one of our webinars this year.
Absolutely. I think first off, what I'd like to do, because there is so much confusion out there, is clarify for all of our attendees today, who are the OEMs that are really the front runners in R-FMEAs and their requirements?
Yeah, I think we prepared a couple of slides. I want to just quickly share my screen here to give you, is it all seen now? Okay.
Yes.
So here you can see all the OEMs that currently have stipulated the use of R-FMEAs into their customer specific requirements. I think the front runners are interesting enough, the French OEMs. I will elaborate on that, but maybe starting with Ford. Ford has just recently brought out, beginning of this year, the new customer-specific requirements, and they're getting very aggressive into this whole topic, not just with the traditional FMEA, but also the reverse FMEA, and also what I've stipulated here is, as of 1st of July this year, there's also an FMEA software usage required. And I can completely understand that, simply because with all this documentation requirements, and now with the R-FMEA on top, I think this is now the time anyway where we have to put Excel to bed once and for all. Interesting enough with Ford is as most of the OEMs require to conduct the RFMEA on a shop floor. So after SOP in mass production mode, if you want to call it that, Ford is a lot more aggressive on that and starts already engaging with RFMEA at equipment manufacturers. So for all these companies out there for new projects in the NPI process that design new machines, new lines, new equipment of any sort in order to drive the mass production at a later stage, Ford is very specific to say start the RFMEA already on that level, which to me also makes a lot of sense. And it's also a wonderful opportunity to rail now our design engineers more and more into these FMEA activities. And then Ford says also after final equipment installation, that is not necessarily after SOP, because remember in your validation phase, when you do your mass production trials and your PPAP trials, you already have your final installation of the equipment, and then also after launch as well. So Ford is the only one that is requiring activities in that area already before we launch after start of production. Then we have General Motors, that's also required. They all require an interdisciplinary approach. This is pretty common for an FMEA approach anyway. And they clearly say after SOP on the shop floor, and documentation, of course, is required by all of them. Here you also have the due dates as of when it's already needs to be followed. Renault also with the interdisciplinary approach, just in a different date. Stellantis, just be careful. Stellantis is not a car brand. So Stellantis is a Dutch investment group that of multinational car maker brands underneath it. So we got to be careful as to what brand is represented by Stellantis. There are the big mergers where actually PSA, the Peugeot and Citroën, and the other big group that came into Stellantis was the former Fiat Chrysler group. So Stellantis only refers in the PSA, Peugeot, Citroën area currently the reverse FMEA. But, and I just recently talked to Stellantis representative. They are currently busy to somehow bring all the car brands underneath under one umbrella. This hasn't been done so far. So Stellantis for FCA doesn't refer to any sorts of RFMEAs, but the PSA group within Stellantis does with a different date. And interesting enough that none of the German OEMs, not Daimler, not BMW or Volkswagen Group, are currently referring to any in their CSRs for these RFMEAs. Ford may be coming back real quick. Yes, interdisciplinary approach. So they also require the design engineers to come to the party, which I believe is a very, very good opportunity now to bring the design engineers closer to the manufacturing process, which is traditionally a huge problem. Design engineers are just too far away from the manufacturing process. Hence, we don't have that interaction, that interconnection with the real customer, which is operations, back to the design boards. So this could be also seen as a very, very good opportunity to bring them to the party. So these are in a nutshell, all the OEMs that are, as we speak, formally requiring the approach of a reverse FMEA, and over and above Ford, also with a very revolutionary, quite right, I must say, the shell use of FMEA software. Excel must be put to bed now once and for all. So these are the OEMs.
There might be a few people upset losing their Excel spreadsheets. Thanks, Hans. You've actually touched on a couple points there now that I wanted to bring up. Was you mentioned traditional FMEAs are not often done correctly or efficiently. And now you mentioned the use of design engineers and bringing software into it. But could you elaborate more on any of the current problems you see out there that actually lead to making the R-FMEA requirement useful?
Yeah, sure. We can do that. Just gonna move the slide forward here. So what you see here is basically the 7-stage approach from the newest AIG VDA FMEA core book, which is a joint approach for any kinds of FMEAs that is recognized on the American side and the European side, if you want to call it that. And this is very much leaned on the previous versions that the German car manufacturers always used in the VDA guidelines. And in this 7-step approach, there is already a variety of issues that we observed during audits and consultations around the world. First of all, there is very insufficient planning and preparation. It's just handled as an activity, and we go on the line and we start. The structure analysis is well in place, I must say. And this is in step number 3, this function analysis is basically where we're breaking down the sub-process level or operational level into each and every handling operation. And this is where we have a big gap. And that's also where we are going to miss a lot of potential failure modes in the complete traditional FMEA approach. So function analysis has been now incorporated, which was not done on a sufficient level ever before. And this is where so many additional potential failures lay. So we need to have a focus point on that. Failure analysis, is suffering because of step number 3, the function analysis, because the process steps are not broken down too much in detail or not enough in detail. Then we have the risk analysis that has been changed now to moving away from a risk priority number to an action priority. The reason why the standard did that is because if you multiply your SOD in the old way with a factor, technically means that severity, occurrence, and detection is carrying the same weight. And this has been changed now to a way to do it with an action priority, which means that the severity gets rightfully so the highest weight, followed by the occurrence, and then followed by the detection. Whoever is not yet using this new approach, I just wanna market this. I know the OEMs are currently not precisely asking and requiring the AIG VDA approach. The only OEM right now is Daimler. All others say we recognize it, but we want different ways, but we recognize it. But a specific requirement is only in the MBST in the special terms of Daimler since 2020. But I can only vouch for this. I think this is the only way going forward, especially because of the step number 3 and having a different focus on the risk analysis from RPN away to action priority. Then we have the optimizations with the current controls for prevention and for detection, which triggers now the ratings of the occurrence and detection. And then we have, last but not least, the documentation, which is now becoming a real real challenge. And Marc will then elaborate a little bit later as to how we work together to get this R-FMEA approach also into a software use. And I think we are in a very good way with our partner of Datalyzer to make this happen and really provide a tool for everybody to master that challenge, because the documentation requirements in FMEA is just getting really a bit much. And the other problems, I would like to call it the trigger points. The trigger points as to why this R-FMEA is so important, and what are we having now actually. All these FMEAs, and I like to call it the FMEA gears, it starts with an issue that we generally don't have sufficient to know management by. And the reputation of the FMEA is also not on a very good level. But if it doesn't become important for management, it's not going to become important for anybody in an organization. And this is where I see a huge gap that needs to be filled, where management has to come to the party. There's no control points in a management review whatsoever. So this is the big starting point. Provision of resources is another thing that should be related to management. Another gear in this FMEA gearbox is, and I elaborated on that earlier already, product design. For the ones of you that are responsible for product design, especially in the corporate world, the product design engineers are disconnected from the operations, and that is a huge disturbance. There is no feedback from manufacturing back to the designs, at least not in a sufficient way. So the disconnect from product design to process is definitely an issue as to why the OEM are stressing this R-FMEA now so much, with also including the design FMEAs, design responsible engineers, as we heard in the example of Ford. Number 3, multidisciplinary approach. The IATF talks about it, the customer-specific requirement talked about it, and we find it again and again, that due to lack of time, and the customer is coming now, so the process engineers sit in their office and just update the FMEAs without that so important multidisciplinary approach. That is also an issue of management. It's not putting the foot down in order to really have the teams work on this risk assessment methodology for the product designs and manufacturing. And operator involvement, often we have representatives from the manufacturing, but the operator involvement itself, we still see and find very poor. Also during the audits where we can observe that. Another issue is the FMEA methodology as well. Not a detailed process analysis. I elaborated before that. So it's too much failure analysis is happening too much on the sub-process level and not so much on the operational level. And this is this method, step number 3, where it breaks down the sub-processes into each and every doing, if I may call it that, in a manufacturing process. Missing IT integration, that is something that has always bothered me. And I think if not everybody of our listeners today was experienced that in auditing, that the PFMEA doesn't talk to the control plan, and the special characteristics identification doesn't talk to one another, and the controls don't fit to one another. And that is often the case when process engineers are the captains of the PFMEA and the quality engineers are driving the control plan. So in that interface, there's a lot of communication issues, but generally IT integration and software usage is still an issue. Cause analysis insufficient, applied. So many times we see just one single failure cause added to a potential failure mode. as we all know, in the 5Ms world of process influencing factors, a potential failure mode can, of course, have a variety of different failure causes. So there we see discrepancies. And the SOD, or the severity, occurrence, and detection rating, underrated also, and we see that all the time, just to avoid further actions. There's no time and it will not be approved and whatsoever, is an issue that I would like to bring forward. Prevention that is not related to the misapproach of the methodology. You must understand, when we start the PFMEAs, that is traditionally in a very, very early stage where there's no tools or lines or machines yet in place. Consequently, we have very little experience and knowledge about the whole thing. So we are giving an SOD rating at the best knowledge level at the time. And nobody's questioning that the engineers are giving that a true reflection of what they think, but due to the early stage, it is at the best knowledge level at the time. So as you run your product life cycle into your process development and in your validation phase and into launch, of course you gain a lot more experiences and knowledge about your production equipment. And often you create this aha effect that wasn't obvious at the early phases. And that's also why the R-FMEA makes complete sense, which is basically not a new methodology. And I want to express this very clearly. The R-FMEA is not another new animal that the OEMs are rushing through the cities. It is not a new method. It is more the issue of not complying to the traditional FMEAs as it should be, because the R-FMEA approach is, of course, part of a standard traditional FMEA approach. Clearly, it was always there. It was not as specifically stipulated as now, but it's definitely nothing new. So that's the prevention. And number 6, of course, in the updates, that's where we have the discrepancy, is also no IT integration. It's not a real living document that we go back to this knowledge database document. That's basically what it is around product and process development. And there's only a forward update when a customer complaint comes, then we updated it in a traditional one, only because the customer requirement says that and the IATF requirement says that. But there's nothing going in reverse. And that's why, and I like to call it those trigger points, those issues that we have during the application of the traditional FMEAs, and as to why the OEMs now feel we have to put the foot down and get the reverse activities into action. That's basically what it is, TARRYN.
Okay, a lot of problems listed there in the current process. Hans, before I move to the next big question, Ryan has asked for clarification on this one. Point 4 of the trigger points, is that PFMEA or DFMEA? It's
technically both. It's I elaborated it strongly because of the CSR on the PFMEA, but the same trigger points apply for DFMEA. No difference. Okay. Perfect. Thank you.
So, Hans, in light of all those issues you mentioned, my interpretation really is that an R-FMEA, it should be considered when manufacturing has started. You've got experience and knowledge. So now you're going back with real data, essentially. Is that fair as my assumption as a non-industry expert? And also, how does the R-FMEA now impact current FMEA documentation? What should be done differently?
It's not so much, TARRYN, as to what needs to be done differently, but I would like to elaborate as to where within those 7 steps that I just presented, where does the R-FMEA now impact each of one of these 6 steps? I think this is the most interesting point that we have to take out of this. So So, and I want to roll this out here. Basically, you have your step number one, your plannings. We just talked about that. Then you do the structure analysis on a very high level of your process structure. Okay, so more technology level, like die casting, plastic injection, trimming, deburring. So on a sub technology level, if you want to call it that. And that in this point number 3 is actually now the requirement of this new standard to break it down to single operations. Every sub-process, break it down. This is where the choose is for so many more potential failure modes, and that boosts the effectiveness of your risk assessment throughout the process chain as well, and also in your design. Then in number 4, the failure analysis, pretty standard. Then we have the step number 5, just moving here this down, the risk analysis, where you do your prevention controls and your detection controls. This is very important now for the reverse FMEA, your SOD rating and your action priority calculation, or RPN if you still use the RPN approach. Doesn't really matter. Then you have the optimization. So you try to mitigate the risk in your initial trial. So your risk is exceeding your risk appetite, as we call it. And then you put mitigation actions in place. And then last but not least, the documentation requirements that come with FMEA. But how does that impact now in the other way around? And I think this is also the importance to understand where in those steps does my R-FMEA now impact and how, with what activities. So I'm going to start here at start number 1. R-FMEA activities shall also be planned. So not just that the process engineers go in there, it's a planned event, if you want to call it. And the French OEMs, Renault, Stellantis, PSA, they also require a planning instrument for that. And this is where you got to be very smart, because the organizations, the companies now have not all the resources available that you would like to have. And I think everybody would confirm that. So all we don't want is just to create another event of actions. And this is where we're going to be very clever. This can be done in your standard audits. If you plan your audits, you can incorporate an R-FMEA approach, and I will elaborate on that a little bit later as well. So there's no necessity to create another series of events for the R-FMEA. So it can be incorporated in a variety of different areas, but I will speak about this later. But there is a requirement also for documentation from the current OEMs. So you would be able to show evidence of the planning activities. It wouldn't so much impact your PFC structure, which is the high level structure of your process flows, simply because if there is significant changes in there, you would rather generate a new FMEA rather than fixing a previous FMEA. That would be then too significant of a change. But in function number 3, clearly, this is a focus point. So with this R-FMEA approach, you try to find potential or additional process steps that might be required, or the potential elimination. Why do I say elimination? Because it's a process that is PPAP'd and now shouldn't be changed without any customer notification. Friends, mark my words. Mark my words. In nearly none of the audits, when I go into a deep dive in a process audit and I find my micro process flow, I will not find the same thing on the paper in real life. Reason being is there is so many audits that are coming towards you, may it be clients, may it be third-party certification auditors, and that goes along with findings, and then actions need to be taken, and it often impacts modifications and changes in the process flow. Consequently, what you see in real life is not necessarily what your microprocess flowchart shows. So this is a very, very important input that an RFMEA auditor, or audit team, I should say, should focus on. Is the sequence of actions still correct? And is the order of action still correct? We also find that it's switching with orders because humans always try to make life a lot easier for them. And that doesn't necessarily get fed back to the process engineers, and it doesn't go back to the FMEA documentation. Consequently, you will see often in many areas discrepancies as to what your PFC, your macro and micro, says to what you see in real life. So that needs to be picked up in the function analysis, because that creates now, in the next step, identification of potentially additional failure modes, or you're adding new potential failure causes. And this is one of the core areas of this R-FMEA, not to revise your rating, we will speak about that, but also to understand from, are there any additional failure modes we have not yet considered in the previous approach when we did our initial FMEA studies. Very, very important. These are the main core ones, as it's in whole a part of a continuous improvement to create additional failure modes we have not yet considered, okay? And basically the redoing or reconsideration of the ratings from the previous ones, which you basically have here. And that might require add-on or replaced, PC stands for preventive controls. The preventive controls trigger your rating for the occurrence, remember. So if you have deviations now in your process flow, if there's an additional operation worked in or one disappeared, it might use an add-on as a process control or replaced, because maybe the process control is currently not effective. And the same with the DC, which is the detective control. This is where it impacts the risk analysis. Do we need additional controls? Can we eliminate current controls even? So it doesn't always go in the negative way, it can go in the positive way as well. And then revise the O&D rating for your occurrence and detection. This is basically where it's coming from, the preventive and detective controls. And that generates now a new action priority calculation. And we see that from all our RFMEAs that we do so far is that there's quite a significant adjustment to the initial ones. And talking more and more to practical data once the mass production is running, because you need to understand before in the planning phase, and I'll show you that later in that PDCA cycle for RFMEA, that requires in the planning phase the study of existing process data, SPC, process capability, reject, rework rates, internal failure costs, customer complaints, audit reports that you have on hand need to be reviewed and studied as a planning activity before you go gamble, before you go into the lines, which is not done in the traditional. Okay, so this is the impact here. And on the optimization, then we might need to add on risk mitigation actions with its responsibilities and due dates, just as you know it from the traditional FMEA approach. And then, of course, which is clearly stipulated, is the collaboration with IPs. In this particular case, stands for interested parties and not for intellectual properties, with interested parties. That can include suppliers, that can include customers, and the internal functionalities that are usually involved in launch processes. And last but not least, in the PDCA circle, the updated FMEA. Marc will show us a little bit later as to how we work that out, what we're working on. And Datalyzer is really, really very far in that respect to get the documentation requirements for all these FMEA approaches now also handled, if I may call it that. And it's going to show you how Datalyzer came up with the solution. Very, very far, also linking with SPC, getting real data from the production line for the FMEAs. But I don't want to jump ahead here, because Marc will then show you this how Datalyzer works as a functionality for the R-FMEA documentation, because the documentation is required. And then, of course, second one, once the FMEA is updated, your control plans and your associated process documents like standard work instructions need to be updated also accordingly. So this, TARRYN, if you ask me what activities actually impact the traditional FMEA, in that sense, I would say you have everything here on one slide that shows you where the impact is to which step, which is a method approach, and how does it go backwards into the R-FMEA.
That's great. I can certainly see the value of an R-FMEA in risk assessment, whether it's product design or process. So that's the impact. Do you want to maybe wrap up quickly, and then before we move to Marc, also, what are the activities that actually go into an R-FMEA now? So that it's clear for everybody.
Yeah, I put this together as a wrap up as to, we call it all the problem solvers amongst you know that there's not only a 5Y approach, that's actually the classical 5W2H approach. Just to wrap this up for you. So what is the R-FMEA? It's a tool for continuous improvement, okay? By analyzing data that are now available that weren't available in the previous times. At Gemba, by reviewing and consulting production staff, if you want to call it that. Why? It all gears up to increase your production robustness. And that is an issue because of the disconnect from the design engineers and also the customers. We have that so many times. Customers want their products every year smaller, lighter, cheaper. Consequently, the design engineers try to achieve this, but at a certain time, you're losing the product robustness. And a design engineer must be careful, because the design that he's providing is actually should be made for manufacturability under process-capable conditions. That's the task of a design engineer. Due to the disconnect, due to this customer demands lighter, cheaper, smaller, the product design swings back and is no longer robust, so that the manufacturing process can cater for all these sensitivities. So basically, we need to bring this back for production robustness, consequently bring the design engineers in to support that. Who? Yes, we talked about the multidisciplinary approach, design engineers, process engineers, quality engineers, operators. I told you Ford really wants you to engage with the operators. Can be many more. These are just the main drivers that we see out there. Where it shall take place at Gemba. Gemba is where the work is happening. So in the lines, in the manufacturing areas, but not only in the manufacturing areas, also in the shipping area, storage area. So in the whole manufacturing environment, if you want to call it that. When? At equipment manufacturers, this is what Ford says, makes sense. At the final equipment installation, remember that can be also in your validation phase according to the product lifecycle before launch, and definitely during mass production. This is where the majority of OEM wants you to be, and can be considered also during the ramp up, maintenance, changeovers, shift change, plant shutdowns, during audits, if you want to call it that, if you want to incorporate it there. How often? Frequently defined by the organization. I just would like you really to advise to respect those trigger points that are presented on a different. I'm not a firm believer in doing it once per year. So my advice would be, guys, by reviewing those data, plan your R-FMEA activities according to a need, and not just to have another event here running. Okay. The OEMs currently are not very specific as to how often you have to do this. It is to the discretion of the company. Be clever and be wise. Create a need first in your planning phase of your PDCA before you and don't overload the R-FMEA activities because you're just taking too many resources away. So the need is important, the very first place. And yeah, and how this is we're referring to the PDA cycle. This is basically what I just said, from the product design phase into the process design phase. In case you're asking what this FD is, this is the foundation DFMEA and the foundation PFMEA. Ford also stresses that in the CSR now. You would commonly know that under generic FMEA or master FMEA. And the M-FMEA would be a machine FMEA. For my liking, too much missing out there. It's a super, super powerful methodology, the machine FMEA, which is interlinked with the process FMEA, and the process FMEA is interlinked with the design. But to summarize that in a PDCA cycle that I believe everybody is well aware of, you would have in your planning phase, you need to scope. You need to understand which line, which manufacturing area, which process, which machine do you actually want to R-FMEA. So you need to select the workstations, line, and machines, basically what it is. You need to prepare the multidisciplinary team, and very important, you review performance data from rejects, reworks, customer complaints, whatever is available, SPC, because the OEM stress very strongly the R-FMEA activities for the special characteristics. This is where you usually have your SPC characteristics running, or your Poka-Yoke elements running, or your 100% controls running if process capability is not proven. So that's what you also need to review in an R-FMEA is your Poka-Yoke elements. Are your sensors operating? Are they really detecting? So this is a very important planning stage before you go into action to Gemba to really look at the performance data that are available. And Marc will also show you how we use now the SPC data from SCs and CCs and link that back to the FMEA. It's the best way of doing that. We have just a very horrible disconnect also from the PFMEA teams to the operational stuff, to the operator. And this is where the data are generated. So we need to feed that back. But Marc will show you this. But then you go into the doing, as I said, on site, in Gemba, wherever you have, and you just compare the real process flow charts in the operations and see what's actually happening online. And you will see deviations. It's actually insane what we find there in audit findings. Then you would check the presence of your preventive controls and your detective controls. We find it all the time that in the FMEA papers you find certain PCs and DCs, and then you don't find them later in the manufacturing process. They've just never been implemented. So this is what the R-FMEA must also pick up. Creation of additional failure modes, that's what you do out there. Reports, okay, and also get your rating right, which is then coming into the control. This is basically the verification, what you do. Are your preventive controls effective? Are your detection controls effective? And your O&D verification. Is that what you see? Is that really justifiable? Why do we have such low occurrence ratings? Why do we have such low detection ratings when we have now found out that we already had repeat failures from customer complaints? How do you justify a detection rating with 2 when the customer is complaining? It's not gonna fly. So this is the verifications for the rating and the controls. And then in your PDCA cycle, then you do your standardization, you update your FMEAs, your control plans, your work instructions. And then, of course, you also have to Yokoten. Yokoten basically means to roll out. If you are in a group of multiple companies doing the same thing, don't keep it for yourself as a hidden secret. Just Yokoten and roll it out and make sure that everybody benefits from that. And customers call it knowledge capitalization, which is basically the same. So roll it out. So this is me so far from the R-FMEA. Marc, I would like to jump in before TARRYN's going to open the Q&A. We got about 10 minutes time for that, a little bit more. Marc, what I would like you to share with our beloved listeners here is how Datalyzer now starts the whole documentation, which folks out there is a potential approach. There is no specific documentation requirements. Other than, and that's what you need to understand, an R-FMEA activity must be traceable to your initial FMEA activity. So there must be a reference what comes out of the R-FMEA. And I believe Datalyzer is very, very far with that. And I'm really chuffed that we have you as a global partner for the ENCONA group, Marc. So maybe you show us real quick how the database is structured, how you come from the initial evaluation, and how you can also run then the documentation by using SPC data and using that in our R-FMEA. Would you do it for us, please?
Sure. Let me share the screen.
So I'm going to stop sharing here real quick.
Yep. Okay, what we as a software company, 40 years in business, what we experience is how do we get the full flow from information from the beginning of the process, design FMEA, process flow, process FMEA, control plan, into the shop floor, and also going backwards. We see that reverse FMEA is basically the answer of the OEMs based on the trigger points you are elaborating. But yeah, if we get this properly organized, then we think that a lot of the information which is required and the integration which is required, that we can do this a lot better than is done nowadays. So what we have here, this is an example screen. Here we have all the FMEAs and the control plans. So all the FMEAs, DFMEAs, PFMEAs, process flows, and control plans are linked. Now let me just open up a very simple example. Let's say we have an example of an FMEA at a very initial stage. So we are not in mass production, it's a very initial stage. So what we've done, we set up the PFMEA, a CNC drilling process. We have requirements that a specific hole is required, failure modes too big, too small, and we also want to monitor the temperature. So we have the cooling temperature. If the temperature becomes too high, that we get some overheating of the drill and we might have damaged holes. So a very simple process. We see with the action priority that we have a few critical elements, that we have a spindle alignment which is not correct, and we have tool wear. Based on these high APs, some improvement actions were done, and that's typically how the traditional FMEA process runs. So we do the performance actions, and we implement SPC, we implement SPC on the cooling temperature, and we get the new severity, the new occurrence, the new detection, and the new action priority. This is basically the starting point that we go into mass production. So what we do is, when we have all these controls implemented, we have to update the FMEA, because otherwise it's not clear what we're going to use on the shop floor. So what we do is we issue this FMEA and we go to the next step. And this is the next step of the FMEA. What we basically did is the new controls and prevention mechanisms we implemented, we have moved into the current controls and the current preventions. and we update the occurrence accordingly and the detection accordingly. And basically the improvements are gone. They are still there in the history, and that's critical because you always want to trace back what happened, what did we do, what kind of things we tried. That's basically your knowledge base. This is basically, if we go into mass production, the starting point of your R-FMEA. So we implement SPC on the diameter, we implement SPC on the cooling temperature, and that SPC application will help us to perform the R-FMEA. One of the problems we see is if you do an R-FMEA, you go into the shop floor and you don't have a proper information system available, then how do you identify potential failure modes? How do you identify the occurrence of problems if it's not properly documented? That's going to be a real challenge. So if you have a proper system in place where you see how often problems occur and what the cause of the problem is, then you can make an effective evaluation of the rating. So how do we do that? We basically implement this information on the shop floor. So now what I have here is, this is the control chart for the diameter. And on the control chart of the diameter, I monitor the bore diameter on the shop floor. And I see a few items. I see, for example, a specific cause in case of a problem. We are going out of control limits. We're going out of specification limits. At that time, the operator needs to assess the process, investigate what the root cause is, put the root cause in. And how does he do that? If he basically looks at the process, we basically have the list of the root causes available. Let me click on the edit and open the node screen. Basically, if we have a problem, the operator can simply identify in the SPC system what is happening. So if he selects 1 out of 1,000 subgroups toolware problem, that gives us immediately what the rating is and whether the occurrence is correct. What we also will see here is that we see that for an operator says, I have no cause found. And that basically means can mean two things. Either the control is not effective, the operator doesn't understand how to analyze the problem and which controls are in place and to find the root cause. So that means we have to train the operator better, and that goes directly into the effectiveness of your controls. Or we have a potential failure mode, which is not in the list of potential causes. And that's basically a trigger to reassess and find the root cause and evaluate if the FMEA is still correct. So how often do you need to perform R-FMEAs? Often, more based on the trigger points, but this is an additional trigger point to what Hans says. The SPC system, if it gives you an indication that something is wrong, is a trigger point to find the root cause, and from this you have to provide feedback to the FMEA process, so they can update the FMEA process according to what is found in the shop floor. The second item is that if we look at PPK values, how capable is the process, those statistics immediately give you an idea how often this can go wrong. So there is a direct link between the PPK value of a process and the occurrence rating. So if we have proper information and we have a proper assessment of the process, we can directly compare the PPK value, which is 0.64, with the occurrence rating and see if the occurrence rating, which was estimated in the initial stage of the FMEA, is correct. Now, how do we document that? Yeah, if you go to the shop floor, you want to make this analysis. So from the FMEA system, we can, for example, export the FMEA. And we put the FMEA in an Excel sheet. So this is an export of the FMEA from the system. And you can simply adjust 1 or 2 columns and say, instead of looking at the corrective actions, we can also put an R-FMEA analysis here. You can do that on the shop floor. You can put your documentation in here, see what the occurrence is originally in the FMEA, and add the new occurrence. And that basically means that with your analysis, you get these kind of analysis on the shop floor. We investigated the problem. We see that the drills from the tool supplier is definitely not according to what is expected based on the initial analysis, and that the occurrence has increased. And this kind of documentation, we can simply put back, if we have done the analysis on the shop floor, we can either link this full document to the FMEA, or we can add the R-FMEA analysis and our conclusions in the recommended actions. So we can simply put this information in here, put the when did we do it, what is the date, what is the kind of action taken, and we put the new occurrence and we update the FMEA again, and then we have a reliable estimation of severity, occurrence, and detection. And of course, then the whole cycle starts again of continuous improvement, taking causes and actions, etc. So this way, we do not only go from FMEA to control plan and put that into the SPC system, we also want to go back and based on occurrence rating, effectivity of control, missing failure modes, provide the feedback. That can be done this way. In an analysis, it could even be done by automatically mailing the FMEA engineer, hey, something is going on in the process. People have these kind of problems. You need to start a re-FMEA process to evaluate what's going on here. That gives you. Go ahead, Hans.
Yeah, thank you, Mark. I think we're running a little bit short on time. I think thank you very much, Mark. The intention was to provide our listeners a way how it can be documented. Folks out there, please bear in mind, there is no specific requirements as to how you document your R-FMEA activities. However, or as long as, I should say, as long as the R-FMEA activities are traceable to your initial assessment. That's the only requirement. Other than that, the auditors and customers will come for you. But as we said, and also in connection with Ford, with having this requirement now to use CAQ software or any sorts of software integration, which I believe is the only way forward to get the integration all the way from the design offices to the shop floor. And there's just simply no other way. Anyway, this was just an extract as to how, if you have any questions to Datalyzer, TARRYN, I don't know, you contact.
Yeah, specifically the first two that came up.
Yeah, because there's also MSA and control plans. There's all the interlinks in the whole APQP process, if you want to call it that. And this is that software integration that's actually missing in our quality work in project and after serial production.
Yeah.
All right, TARRYN, on the dot, 5 o'clock. I think.
Well, if you guys have 10-15 minutes to stay on.
Sure.
Sorry, everybody, we're running a bit long. If anybody is popping off, I do record these and I will release them via our blog and podcasts. It should be by the end of the week. Yeah, I've got quite a few questions here, and the first two questions were indeed, and I joked and said people are going to be upset about the Excel spreadsheets. And so I'm going to ask you both in one go, kind of, Mark. Please elaborate. Why must Excel be put to bed? What's wrong with it? And then Christoph mentioned that, sure, Ford is requiring software, but Excel is actually software. So why can't we use software?
Yeah. Okay. Let me maybe be a little bit more precise in that. It's not Excel per se that we should put to bed. It's and Excel, as we all know, is an extremely powerful Microsoft Office tool, and of course it's software. And I think it can be stressed to the extreme to incorporate all these documentation requirements that we see out there. So not put Excel to bed per se. What I was referring to is the way the companies use Excel for FMEA is just not helping. But if somebody is clever, and I know even a German probably is coming from this person anyway, they cover these requirements on an Excel version because they're experts and they're using Excel to complete different levels, and then it can work. But the way Excel is used for the FMEA, that's what I was referring to. That way we have to put to bed, and not Excel per se. So maybe that's more correct.
I want to elaborate a little bit and on the risk that I'm being commercial, but you can't do the requirements in Excel anymore. Excel is not a database system. I give you a few examples. How do you want to manage your actions in Excel? You have hundreds and hundreds of actions across multiple FMEAs. That means that you have to copy and paste all these actions in the system to manage that properly. But one item which is interesting, we're going to talk about foundation FMEAs where you use standard processes and you want to link them to specific FMEAs. But it needs to be a living document. So it's not a matter of copying a standard process. If you upgrade a specific FMEA, automatically the standard FMEA needs to be updated.
Yeah. Okay, Mark, let's not go further in that.
No, but there are in summary, I understand. There are some reasons you can't get this done.
No, that's fine. That's fine. We can do this offline.
Yeah, sure.
And the other question.
So yes, I got quite a few here. From Raul, so is the main role of the R-FMEA then checking the effectiveness of defined measures or identifying other potential missed failures?
Well, identify new failure modes, verifying the effectiveness of or the accuracy of your ratings.
Mm-hmm.
Yeah, that's what it is. So it's both.
Effectivity of your controls as well. Yep.
Yeah, and the effectiveness of your current controls. Yeah.
Okay, great. Okay, I've got quite a few questions there from Andre. First one. In case of built-to-print suppliers, for how to involve product design into the reverse PFMEA, they don't care about how other suppliers will organize their processes. It's another company. Thoughts?
You're buggered. You're in trouble. Yeah, we see this on the corporate world or in companies, medium companies with remote functions, with product design. I perfectly know how difficult it is to get these kind of information and to rail them in, especially on remote functions. Yeah, relation management. That's all I can say. But it's a problem. It's clearly a problem.
Much bigger, longer answer there. Maybe a mine. Again, from Andre, since RFMEA is based on quality data, does it mean that the responsibility for leading, planning, and tracking RFMEA should be on the quality department? Is it all quality data?
Not necessary. Well, it depends on how you organize the functions. Let's say 8 out of 10 companies we get to see, the process engineers are spearheading the PFMEA, not quality. The quality is part of the team, but process engineers are 8 out of 10 times in charge. So, and it's clear the process engineers are providing capable processes and lines for their customer, which is production. Mm-hmm. And it's his obligation to get in control of the risk and secure his customer, which is production from all this happening. So there's no requirement as to who, but 8 out of 10 is process engineers are driving the PFMEAs. Okay, and this is where the interface problem comes in, because the quality engineers usually run the control plans, and this is where the disconnect comes again if the communication is not strong. Okay, so my advice would be leave it with the process engineers.
And some advice being asked here again, it's an interesting one. Can a customer or should a customer representative participate in reverse FMEA activities at the supplier? Internal defect rates are not usually shown to the customer, so you wouldn't want them displayed as potentially bad triggers. Or should it be reported and agreed some actions?
Nope. No.
We often see more and more that customers are not allowed to get a copy of the FMEA. They can review it, but they're not getting a copy anymore. So putting them on the shop floor, it might be interesting, but
Mark, that has always been that way. But customer, I would not invite for an R-FMEA. That's for certain. Full stop. Full stop.
Okay, that's a categorical one.
That's a no.
Good question from Sandiso. Can I still use an R-FMEA can I use an R-FMEA as an initial start if I have no processes in place at the moment?
No, you cannot, because in order to start the R-FMEA, you need practical data, process data, which you don't have at the beginning. That's why it's one of the launch points and trigger points to come back once you have the initial more theoretical analysis, and then reinforces with the practical information and see where we went wrong or where we had an underestimation, because these engineers don't do it wrong on purpose. You know, it's just they don't have enough experience with the lines and products at a given time, which is in a very early phase. So no, you cannot.
Yeah, it's the best educated guess to start versus what was the reality.
Yes, exactly.
Hans, I think maybe Hans or Mark, for the last question, maybe for today, from Manuel. How does the R-FMEA fit into MLA, the maturity and level assurance process?
Sorry?
How does an R-FMEA fit into the MLA process? Or in ML7, you're closing off, you're launching that whole thing, and that's actually when your R-FMEA starts. So it's not directly affected in MLA, in nowhere from ML0 to ML7. But what you should do is in ML6 you start planning R-FMEA activities. That's what you can do. But else there's no direct impact in the MLA stations. But I saw just an insert, a question from, and I think this is a friend or colleague from Autoliv, because they have the question was, is the PFMEA go see fix activity, would that cater for an R-FMEA activity? Yes, it would, definitely. You just gotta relate it to the references of the initial one. So that particular standard that I know from this company, so the PFMEA go see and fix, can be used definitely for R-FMEA activities with the reference in the documentation. Yes. And go see and fix in general as part of the Toyota production system, yes, can be in general used to document. There's no specific requirement. Perfect, thank you. One here, I think this is, let's clarify nicely for everyone. Are the R-FMEA and PFMEA, should they be maintained as separate documents, or does the update logging, is that okay? Does that suffice?
Yeah, this is, it technically can be done either way. As again, there's no requirements, but basically you must understand you have your initial assessment, then your risk appetite is too high, and then you have on the right-hand side your actions and your reassessment. Those two parts are the initial one. So if you now move the right-hand side, the optimization, into the left-hand side, as Marc showed, then you have the right-hand side for your R-FMEA activities. And then it talks to one another by running it as a standalone R-FMEA with the reference to the initial one. It can be either way, but...
yeah, the advantage of integrating it is that you have the history clear, and that
exactly
you have new engineers coming in and they want to understand what happened in the past. And if you have that in one list of documents, that's easier than they have to go in all kind of cases and figure out how this happened and how this occurred in the past.
Exactly.
Yeah. Hans and Marc, I'll take these last two questions if you still have time. Are you
You make
suggesting?
time.
You make time. Are you suggesting that an RFMEA is a reaction to the misimplementation of a D or P FMEA?
To the
To the misimplementation?
partly part of this, and the other part, the other reason is which the design engineers and process engineers can't really solve with their teams is that lack of knowledge about the process and experiences under serial conditions. You can't know it all because it's a preventative tool. And you're discussing potential failure mode that have not yet occurred. So you can't know it all. And that's why I would answer this question with no, it's not just the misuse, but over and above, it became extremely important for the OEMs to emphasize that R-FMEA, because we talked to all of the OEMs and they just had enough with all the FMEAs they see out there. Just had enough. And I wouldn't be surprised if the other Germans roll it out during time as well. And it makes sense. It makes complete sense, but not as a new methodology. It's actually part of the traditional FMEA approach in any case to re-verify. It's always been in the books. It just wasn't identified as such.
I think it's also a formalization of trying to get it a living document. People struggle to get it a living document, and this is more a formalization of the OEMs to make sure that this is done, and so they can verify and audit on it.
Yeah, that makes sense. A clarification from Prakash. So the SO and SD matrix to prioritize high, low, medium has not been discussed. Does that not apply for an RFMEA?
No, the severity is basically not part of the R-FMEA because the severity normally doesn't change and is not updated. So the SO and SD matrix are not part of the R-FMEA. It's basically the occurrence and the detection which are reviewed and evaluated, especially the occurrence.
Yeah, that's what the book says. I have seen it. That the initial assessment of the severity was completely off, simply because of the disconnect from the design, simply because we didn't really know the impact of the failure of this part in the vehicle. Consequently, we came in with a very low one, which then they found out with a lot more knowledge at a later phase that we are completely wrong. So it's not that you cannot, in the traditional one, you don't touch the severity. In the reverse engineering, if you clarify as to the understanding as to why, it's not entirely wrong to do it. Okay, but the focus points are occurrency and detection. But if you change the severity even with the given explanation as to why we were completely off in the initial one, no auditor will give you a finding for that. Yeah. But focus is occurrence and detection.
Perfect. Thank you very much. I apologize if I have missed any other questions that were going on in the chat boxes. Thank you, Hans and Mark, for sharing all your thoughts today. We've had really great comments.
Pleasure.
You're welcome.
As always, we run a bit long. Just to confirm for everybody, I will share, I'm sure Hans will part with his slides. So I will share slides and recordings by the end of the week.
Cool.
Okay. Thank you
very much. Best of luck.
Good evening, everyone.
Bye.
Bye.